In this video, we're going to use the kube-prometheus-stack to install Prometheus and Grafana on Kubernetes. I'm going to show you how Prometheus is already configured to monitor the underlying Kubernetes infrastructure, and how we can configure Prometheus to monitor our own applications. So Chapter 1 covers installation, Chapter 2 covers infrastructure monitoring, Chapter 3 application monitoring. This is going to be very easy and lots of fun, so let's jump right into it. All right, so inside of your terminal, command prompt, or shell, write the command Helm version to ensure that you have Helm installed on your machine. If you do get a version, perfect. If you get something to the contents of command not found, please make sure to check out the article where I show you how to install Helm on Mac or Windows. Link is inside the description. Once you ensure that you have Helm installed, we're going to use it to simplify the deployment of what's considered a very sophisticated setup, the kube-prometheus-stack. Okay, now for those that aren't very familiar with Helm, I'm going to keep it simple and start by discussing what it is at a high level. So we have this concept of Helm repositories, where a repository contains many Helm charts. A Helm chart is essentially a package that combines and already contains all of the configuration files needed to set up a particular software. So to give you an example, a popular repository is Bitnami because it contains many Helm charts that simplify the deployment of very popular software like MongoDB, Redis, MySQL, PostgreSQL, in such a way where they can be made very highly available within your Kubernetes cluster. Okay, now the Helm repository that we're interested in this particular video is the Prometheus community Helm repo, because it contains all of the Prometheus related Helm charts, which one of them we're going to use to set up the kube-prometheus-stack. All right, so here is the link to the Prometheus community Helm repo, which contains a lot of Prometheus Helm charts. We need to refer to this repo from our local Helm configuration. So here we need to say Helm repo add, and we're going to set an alias by which we can always refer to this Helm repo. You can call the alias whatever you want. I'm going to call it Prometheus Community because that makes the most sense. And we need to link this alias to the following Helm repository. Okay? And now that we've added this Helm repositories, we can actually look at all of the Helm charts inside of it. So I'm going to say Helm search repo, and I'm going to search for the Helm charts inside of this repository. And there are many Helm charts. If you scroll up somewhere, you'll find the kube-prometheus-stack Helm chart, the one that we're going to use. Now, if for some reason you weren't able to find it, you can zero in and refine your search by saying Helm search repo. We can search within the Prometheus community Helm repo for the kube-prometheus-stack Helm chart specifically. And there it is. We see this Helm chart where the latest chart version is 65.5.0. What if we want to search for all of the versions that are available for this Helm chart? We can say -- versions. And if there's a version in particular that you're interested in installing, you can feel free to look through all of the chart versions and make sure that they're available. In this case, I'm interested in installing the kube-prometheus-stack version 45.7.1. So when I say installing a Helm chart, what does that mean? Let me start out by writing the command, and I'll break it down as I go. Okay, so I'm going to say Helm install. So when you install a Helm chart, you're essentially taking that package of configuration files and releasing it into your Kubernetes cluster. So every Helm chart installation is known as a Helm release. We're going to call the release Prometheus. You can call the release whatever you want, okay? And the chart that we want to install is inside of the Prometheus community Helm repository, and it's called kube-prometheus-stack. The version of the chart whose contents we want to release onto our cluster is 45.7.1. Please use the same version of me for consistency. And now the contents of the kube-prometheus stack, I want it to be deployed within a particular namespace in my Kubernetes cluster. That namespace is typically called monitoring. And we need to first make sure that that namespace gets created before the Helm installation proceeds. So we can say create namespace. All right, and that should be it. And so by installing the kube-prometheus-stack Helm chart, we're releasing 4 main components into our Kubernetes cluster: the Prometheus operator, the node exporter, kube-state-metrics, and Grafana. The Prometheus operator is crucial because it automates the creation of your Prometheus instance as well as the alert manager. The Prometheus instance is essentially a time series database that's going to store all of the metric data, whether it's infrastructure related metric data or application related metric data. All of that data will reside inside of Prometheus. Okay? And it also automates the creation of the alert manager, which can create alerts based on the metric data that's inside of Prometheus. 2 other components that get deployed are the node exporter and kube-state-metrics. Those essentially work together to extract infrastructure-related metrics from the Kubernetes platform itself, and they're automatically set up to persist all of that data into Prometheus. So right there, we get infrastructure monitoring out of the box. Okay, and now you've got all of this metric data inside of Prometheus. How are you going to make sense of it? Well, we also got Grafana for free. Grafana is a visualization tool that can query metric data from Prometheus and based on that data, create very insightful visualizations. How do we actually make sure that we get all that and I'm not just out here lying to you? Well, we can look at all the pods that get deployed in the monitoring namespace. So here we see the Prometheus operator, which automates the creation of your Prometheus instance, as well as the alert manager. We see kube-state-metrics and node exporter, and we see Grafana as well. All right, and now if you've never heard about Helm or the concept of operators before, this might have been a bit overwhelming to you, in which case I would suggest checking out our complete Kubernetes course where we cover all of these essential Kubernetes concepts in a lot of detail. But for the sake of this tutorial, just know that through a simple Helm release, we were able to deploy the entire monitoring stack. Okay, now it's time for part 2 where we explore how the monitoring stack was already configured for infrastructure monitoring. So the gist of it is Prometheus relies on exporters to extract metrics from particular targets. For example, a MySQL exporter would be designed to scrape metrics from MySQL. A MongoDB exporter is designed to scrape metrics from MongoDB. In this particular case, by deploying the kube-prometheus stack, we get 2 exporters for free. The node exporter, which is designed to scrape metrics, system-level metrics from Kubernetes nodes, like CPU, memory usage, disk utilization. And we've got the kube-state-metrics, which is another Prometheus exporter. And this one is designed to collect metrics that allow us to monitor the health, configuration, and availability of all of your Kubernetes objects, your pods, deployments, and your services. And because both of these exporters are already shipped as part of the kube-prometheus-stack solution, the Prometheus instance is automatically configured to pull all of the metrics being collected by these exporters. So it's pretty cool if you think about it. We already have Kubernetes infrastructure-related metrics being saved into our Prometheus database, and we can access all of them right now. What I'm going to do is say kubectl. I want to get all of the services that were deployed as part of our Helm release. The service I'm interested in is the following because it will allow me to access a Prometheus UI that I can use to make queries against the Prometheus database. So I'm going to port forward the following service. If you don't know what the concept of port forwarding means, again, highly recommend checking out my Kubernetes course. kubectl port forward. The service is in the monitoring namespace, and the service is called Prometheus operated. And the port I want to forward is 9090, and we'll just forward it to a host machine port of 9090. So now if I go localhost 9090 right over here, I can access the Prometheus UI. Kube pod container, I don't know, status running is a metric that would be collected by the kube-state-metrics exporter. And this gives us information about pretty much all the pods in our cluster. A value of 1 means the pods are running. A value of 0 means whatever pod is failing for whatever reason. All our pods are good. And so it's really hard to kind of look at all of this data when it's in vector format. And that's when something like Grafana is really handy, because it allows us to create very insightful dashboards based on all of these Prometheus metrics, okay? So these queries that I'm performing right here using the Prometheus UI would also be done from inside of Grafana, except Grafana has a way of converting these queries into insightful panels where we can see how these values are changing over time. Okay, so what I'm going to do is go back over here and say kubectl port forward. This time, the service I'm interested in is the one that will allow me to open up the Prometheus Grafana UI. And I want to port forward this port 80 into port 3000 of my machine. Okay. So now if I go to localhost 3000, I can log into Grafana. So the username, the default one is admin. The default password is prom operator. Let me try it out. Now, if for some reason these credentials don't work for you, what you can do, I'm just going to stop it for now. I'll come back to it. What you can do is say kubectl get secret-n monitoring. The credentials are saved inside of a secret. Don't know what a secret is? Check out the Kubernetes course. -n monitoring Prometheus Grafana. So this gives us the secret. We want to extract its contents. So I want to output its contents. I can use the -o flag, and I want to format the output using JSON path. And the field whose value I want to get is .data, .admin password, and damn it. Let's try this again. And I can pipe the output so that I can base64 decode it and then print out the value. Prom operator. So if you use this command, you'll be able to extract the password. All right. Let me go back and report forward. Grafana. Localhost 3000, we're good. And if I go to browse, and notice how Grafana has been pre-configured with dashboards that query Prometheus. So if I navigate to this dashboard, each panel over here is actually a query that's being made against the Prometheus database to visualize the metrics that were collected by Prometheus from both system-level sources, in this case via the node exporter, or Kubernetes-specific metrics. Okay? So this dashboard over here allows us to visualize all of the Kubernetes-specific metrics, the amount of running pods in all of the namespaces, the amount of running containers, so on and so forth. So it's pretty cool how we get the ability of infrastructure monitoring out of the box without having to do anything. All right, now it's on to chapter 3, where we explore application-specific monitoring. So how do you monitor an application on Kubernetes? Well, first, you need to develop your application in such a way that it can expose metrics in a format that Prometheus can understand. Many applications, many web frameworks like Spring Boot, Flask, Nest, they all have dependencies, Prometheus clients, that can instrument these apps to expose Prometheus metrics. It's actually very simple. I wrote 4 separate articles that describe how various types of apps can be instrumented to expose Prometheus metrics. So like Spring Boot apps, Flask apps, Nest.js apps. If you're curious, feel free to check out the articles, links in the description below. But anyways, once you've developed your app to expose Prometheus metrics, Then you deploy it in Kubernetes alongside a cluster IP service that can be used to access the application. And so now how do we configure Prometheus to find this application's endpoint where it's exposing all of these metrics and scrape this metric data every 10 or 15 seconds? This is where ServiceMonitors come into play. You'll remember that we used a Prometheus operator to automate the creation of our Prometheus instance. If you took my Kubernetes course, you'll know that an operator is a custom controller that extends the Kubernetes API and can therefore watch for custom resources that aren't native to Kubernetes. One such resource is the service monitor. Okay? And what a service monitor does in this case, it binds to your service by matching its labels. And as long as that service monitor is discoverable by Prometheus, it will configure the Prometheus instance to find your service, direct it to the application's endpoint, and scrape its metric data in regular intervals. Okay, that's enough theory. Let's put it all into practice. So here is a repository where I uploaded all of the configuration files you need to set all of this up. Link is in the description. Go to code, copy the URL that we need to clone this code. On a separate terminal, choose whatever directory you want in your local machine. Clone your code, or clone the repo, I should say, somewhere where you can easily access it. And then what we're going to do is apply every single configuration that's inside of this directory. Okay, git apply-f, apply everything in the current directory. Why am I saying git? kubectl apply-f. Okay, I already had them deployed because I was preparing for this lesson beforehand. So let me clear the output. And now let me go inside of the deployment.yaml. So this just deploys a fast API application that is serving requests on port 8000. This cluster IP service allows us to access our fast API app. So what we can do is say kubectl get services -n. Everything is being deployed in the monitoring namespace. It doesn't really matter what namespace you deploy these resources in. I just chose monitoring because that's what we had already, and I don't want to proliferate too many namespaces in my cluster. So kubectl get services -n monitoring. All right. And the service that I'm interested in is the fast API app. So I'm going to say kubectl port forward. I want to port forward the service object fast API apps' internal port 8000 to a host machine port 8000. And we need to specify that this Kubernetes object is in the monitoring namespace. Okay, so now if I go ahead and say localhost 8000, oh, spoiler alert. So this is the fast API application, and this application, I programmed it to expose metrics at the path/metrics. And if you're interested in how to instrument an application to expose Prometheus metrics, whether that's Spring Boot, Fast API, Flask, whatever, again, all the articles are in the description. But anyways, here we see different types of metrics that give us various insights about what's happening in this app. So here, one metric is the total number of requests that's being made on the empty path. So if I make a few more requests to localhost 8000 and I just refresh this, you'll see that the metrics get updated. 11 requests in total were made on the path / and 147 requests were made on the path / metrics. Anyways, because metric data is constantly being updated, we need Prometheus to regularly scrape this metric data so that it stays up to date on what's going on with this app. All right, so if I go back, here we have a service monitor, okay? This part is really crucial because it matches the labels of our Fast API service. The Fast API service is what allows internal access to our Fast API app. So this basically configures Prometheus to find our application. And then once it finds our app, this tells it which port our app is serving requests on, the port named web on the internal port 3000. Okay, you can just use the port name. And the path where the app is serving requests is /metrics. So right there, the service monitor gives Prometheus all of the information that it needs to find our app and scrape all of the app's data at the appropriate endpoint, port 8000 path /metrics. Pretty cool stuff. And this is really important as well, because if I say kubectl get the Prometheus instance inside of the namespace monitoring, and I want to output its labels in a YAML file, one important field is the service monitor selector. The Prometheus instance was installed in such a way that it can only discover service monitors that have this label, release Prometheus. So in order for the service monitor to be discovered by Prometheus, you need to make sure that you give it this label. It must match the kube-prometheus-stack release label. And that's basically all we need. We've already gone ahead and applied all of these configurations, but in case you didn't, kubectl apply -f. All right, and now what we want to do is ensure that Prometheus is actually able to discover the service monitor and therefore scrape all of the data from our Fast API app. So what we can do is remember that port forward command from before where we access the Prometheus UI. Yep, this one right over here. Let's go ahead and say localhost 9090 and access the Prometheus UI. If you go to status, targets, boom, it found our service monitor and is monitoring the Fast API app at port 8000 /metrics. A state of up means that our application is healthy because Prometheus is able to find it and collect metric data from it. So by this logic, all of this metric data, let me open up, let me report forward. So by that logic, all of this metric data should be saved inside of Prometheus. Let me copy one of the metrics. So total number of requests made to the path / is 11. Are we going to see that in the Prometheus database? Let's run that same query from the Prometheus UI. Indeed, we do. So all the data is now being saved in Prometheus. How do we make sense of all this data? Well, that's where Grafana dashboards come into play. So I already created a Grafana dashboard and exported its JSON. You've already deployed it as a config map, which will automatically get discovered by Grafana by virtue of having this field, Grafana dashboard 1. So now if we go ahead and port forward the port that we need to access Grafana, we can see that we've got this Fast API application dashboard. It's monitoring the request rate of our app. Let's do it in the last 5 minutes. Beautiful. And this panel could be fixed, but I'll do it in an upcoming lesson. The take-home message is each of these panels is a query that's being made against the data in the Prometheus database. So if I edit this panel, all this is a PromQL query. You can perform that exact same query in your Prometheus UI if you were to rerun it. But anyways, Grafana will get the results of this query and allow you to visualize it over time. Pretty cool stuff. And that's pretty much it. I hope you enjoyed this lesson. If you enjoy my teaching style, don't forget to check out the Kubernetes course, and I will see you in the next one.